Hi again, everyone. Chris Tisdell here again. Thanks for tuning in. In this presentation, I'm going to continue my series of videos, A Beginner's Guide to Calculus. And I'm going to concentrate on functions. And in previous videos, we've talked about functions, the need for functions, what is a function, domain, range, sketching, graphs of functions, all sorts of things. In this presentation, I'm going to look at piecewise defined functions, aka split functions. And I'm going to do an example. So, in the previous video, we defined what a split function was. Now, basically, a split function is just a function that follows one rule some of the time and a different rule another part of the time. Okay, it depends on the value of x for a function f of x. Now, these kind of functions are called piecewise defined functions or simply split functions. Now, this is an algebraic way of writing a split function. So there's one function, say, over here that's your g of x, and that's a little graph of it. And there's another function, say, h of x over here. And you can see that the function changes at the point A. Now, in this picture, I've got a little jump, but that's not strictly necessary. It could be like this. So in this example, g of x would be x and h of x would be negative x. Okay, so what is the example that we're going to look at today? Well, consider the following function defined in this piecewise or split manner. We're asked to compute three values of f. F of 0, so the value of f when x equals 0. F of 1, the value of f when x equals 1. And similarly, f of 3. Now, you don't need to draw a graph to do these problems. It's pretty easy. You can see the change occurs at 1. So depending on whether the inputs, greater than or equal to 1, or no, sorry, greater than 1 or less than or equal to 1, you know it's this bit or it's this bit that you're working with. Okay, so let me just do it algebraically first. Okay, so let's work out f of 0. Okay, so 0, the input, is less than or equal to 1. So this input is less than or equal to 1. So this is the function this is the part of the function that we're dealing with. Okay, so 0 is less than or equal to 1. So f of 0 is this function, or this part, evaluated at x equals 0. Okay, by this square bracket, I mean this function evaluated at x equals 0. So let's replace x with 0. So 7 minus 2 times 0, that's just 7. Okay, pretty easy so far, right? Let's go to the next part. What is the value of f when x equals 1? Now, you can see at x equals 1, that's kind of where the change in the split function occurs. So, for x equals 1, well, it's not this bit. It's this bit because x less than or equal to 1 aligns with x equals 1. So again, this is the function that we want to deal with. Okay, so let's replace x with 1 in here. So 7 minus 2 times 1, 7 minus 2, that's 5. And lastly, f of 3. So you can see the input 3 is greater than 1, so it's here. So this is the part of the function that I'm interested in now. So let's work with that. Okay, so finally, f of 3. Okay, so we're in this zone here because 3 is greater than 1. So that's the function that we want, the part of the function. So if I replace x with 3 in here, I get 12 plus 1, 13. So you can see those examples are pretty easy. You just need to work out which part of the split function is the right one to work with at this particular point. Okay, now you can also draw graphs. So let me just draw a quick graph here. Actually, I'll squeeze it in up here. So this isn't to scale, this is just a rough sketch. All right, so for x less than or equal to 1, we've got the graph 7 minus 2x. Okay, so we worked out that f of 1 was 5, and the y-intercept is going to be 7. So it's going to cut somewhere here, and that might be 1 there, and that might be 5. So it's going to go through those 2 points there. So let me see if I can just squish this in somehow. Okay, great. And we've got 4x plus 1 for x greater than 1. So that will be have a steeper gradient because the gradient's 4. And it'll actually line up with this curve here. So it might look something like this. Okay, if you go out to 3, you'd notch up the 13 on the y-axis. Okay. Now in this case, the split function lines up at the change point. It doesn't always line up. There could be a jump, but in this case, it does line up. Okay, that's a basic split function example. Hope you enjoyed it. Hope you can join me for more videos in the future. If you have any comments, any questions, put them in the comment section below. Thanks for watching, everyone. See you later. Bye.